All right, so today's tip is going to be a randomly generated page number. We're going to grab a page from Maintenance and Reliability Best Practices by Ramesh Gulati, third edition. And we are going to open up to that page, whatever topic happens to be on that page. We are going to give you a practical tip today regarding whatever happens to be there. So let's see. We've done a process improvement here, I hope, and we've got a pop-up screen so I don't look ridiculous. Don't forget, vote for your favorite number. My guess today is 291. Let's see what we got. Probably not 291, but let's see. Oh, 111. All right, so we've got 111. We are going to turn to page 111, and we are going to see what we got. Page 111. Page 111 is the summary of the future of maintenance. Ooh, it's actually the whole understanding of maintenance. Wow. So we're going to summarize understanding maintenance. That's awesome. Maintenance practices can be classified in a bunch of categories. He's got all kinds of stuff like condition-based and preventive and all the various things that we do, breakdowns, planned work, all that stuff. Let's break this down as easy as we can. You've got 4 jobs in maintenance. 4. 4 main jobs. Ready? Number 1, don't shoot yourself in the foot. Don't be the source of problems. What does that mean? That means do the right work. So if we're going to do a preventive maintenance activity on a piece of equipment, it should be the right tasks that address failure modes. If we're going to do inspections, we should be doing them with attention and attentiveness and really looking to see if there's a defect. We have to, when we do work, when we do repairs, we should do it with a level of craftsmanship that makes us proud to step away from the work. So we don't want to shoot ourselves in the foot. Do the right work, do it with precision. Use things like torque wrenches. All right. Number 2, slow down degradation. Now that we did things with a level of precision, we did the work right, level of craftsmanship's good, we want to slow down the decay rate of an asset. If we slow down the decay rate of an asset, then the defect happens later that causes the PF interval. So we want to slow down degradation. We do that by lubricating things properly, by aligning them and balancing them properly, by making sure we centerline our manufacturing lines, all the things that we do that reduce decay. And we want to manage our lubricants, right? So not only lubricate properly, but manage lubricants. That's number 2. So, number 1, don't shoot yourself in the foot. Number 2, manage decay. Number 3, since parts are going to fail anyway, if I can know in advance, you should know in advance. So number 3 is know in advance. Assess for condition, whether you're using ultrasound or vibration analysis or infrared thermography or oil analysis. Since it's going to decay anyway and give you an indication that that defect now exists, why would you not want to know in advance? Let's see. Should I let my assets fail at a time where I'm in the middle of production and it's not convenient, or I got to come in at 3 a.m., or should I know in advance, be able to work with operations to do it when it's least impactful, not always no impact, but least impactful to the operation, plan, schedule it right, and do it at my convenience? Which one of those 2 things should I do? So we want to know in advance. 4th thing, do all the other things effectively and efficiently. So have a good work management process. Don't go out and do jobs you're not ready to do. Plan and schedule work. Get it done well. 4 things you have to do in maintenance. That's it. We make stuff so overcomplicated. All of this sits around. Don't shoot yourself in the foot. Don't be the source of problems. Slow down degradation. Know in advance and do things efficiently. That's it. Do those things and you're in good shape. But it takes an awful lot to do those things well. So read maintenance and reliability best practices, reach out to Reliability X, like and subscribe, and we'll see you next time.